Under the subject of manufacturing technology in degree semester 5 in mechanical engineering department, today we are going to see the experiment number 12, which is to study about the basis of resistance welding. So resistance welding is a pressure welding process in which the heat required for joining the metals is obtained by the resistance offered by the workpiece to the flow of electric current through them. So in this welding process, no filler metal or flux is used. The joint is formed due to localized heating and pressure applied by electrodes. So let us first see the principle on which the resistance welding works. So the principle is when an electric current passes through two metal pieces in contact under pressure, the electrical resistance at the joint generates heat according to Joule's law. And what is Joule's law? Joule's law is H is equal to I square RT, where H is heat generated, I is current, R is electrical resistance, and T is the time for which current flows. The heat is concentrated at the interface, which is contact surface of two metal pieces, causing them to soften and fuse. The pressure applied by the electrodes ensure proper bonding as the metal cools. This is the schematic diagram for which represent the resistance welding. You can see the step down transformer. Step down transformer is used to get the high ampere current and low voltage. So it will supply the high amount of high ampere current. You can see the fixed copper electrode and movable copper electrode. These two electrode will ensure the contact between two sheets. You can also see the heat affected zone at which the welding will take place. So this is the schematic diagram for resistance welding. So let's first now see the basic working steps. The first one is preparation. So clean the metal sheets to remove rust, oil or paint for good electrical contact. Then positioning. Place the workpieces between the two electrodes of the resistance welding machine. So apply a predetermined electrode pressure to ensure close contact. Then pass a high current which is of a 2000 to 10,000 ampere for a short duration from 0.1 to 0.5 second through the joint. Due to resistance at the interface, heat is generated, the metal melts locally and weld nugget will form. Stop the current flow, maintain pressure for a short time and allow the molten metal to solidify under pressure, forming a strong joint. There are different types of resistance welding. The first one is a spot welding, joining overlapping sheets at small circular spots. Second one is a seam welding. It produces continuous welds using the rotating wheel electrodes. Third one is a projection welding, uses projections or a raised portion to localize current and heat. And the fourth one is a butt welding, end-to-end joining of a rods or wires using resistance heat. Now let us see the different applications of a resistance welding. So first one is a automotive body manufacturing, spot welding of a car panels. Second one is a sheet metal fabrication. Third one is a airplane and refrigerator bodies, and the welding of wire meshes, tubes and small components. So we can say that the resistance welding has a universal application in different fields. That is why resistance welding is very much important in the manufacturing technology.